Hello all. We are going to have another important topic like board plot, which is called as polar plot. And here in this video, we are going to discuss about the introduction and the procedure. So this is very interesting according to me. So students love to represent the graphical representations rather than definitions. So this polar plots are important. Like all these are different methods to analyze the stability of the system. So if we consider board plot or polar plot or Nyquist plot or root locus, so all these graphical representations mainly gives the stability analysis in electrical engineering. So, frequency response evaluation for complex systems, which is a real world problem, and need for rapid stability assessment. So, who is going to be affected? Like power systems, motor control, and aerospace industries. These people are going to be affected. And what is the impact? Not going to consider this problem. So, before learning every topic, plays a major role, like what is the real world and who is going to be affected and what if the impact is not solved. So, if not solved, then the system instability leads to the equipment damage and financial loss and safety hazards and operational risks. These are the impacts if we are not going to consider this problem. So coming to after board plot, we are soon after learning about the polar plots. So what is the limitations in board plot and what are all the advantages in polar plot? So in board plot, we have separate plots required. For magnitude and phase plot, we have different graphs. And it is time consuming analysis and it is a limited frequency range, that is logarithmic scale may obscure low frequency behavior. When we compare this board plot with polar plots, here we have a single plot which combines both magnitude and the phase. So calculations is also very less. Also, if it is enough if we complete one graph alone. Then this is rapid stability assessment like quick gain and phase margin determination and visual frequency response like complete system behavior in one view. That is in which plot it comes and which order it is. So here we can easily assess either the plot that we are going to draw is either right or wrong. Like based on the order and type of the system, we can analyze in which quadrant that our values should be. Coming to the introduction of polar plot, so this here also we have magnitude and the phase but combined together and we call it as concentric circles. This is done with the polar plot, radial lines, positive angles and negative angles. Coming to the procedure, the first step will be, the question will be in a transfer function, and with that transfer function we have to determine the corner frequency, and from after corner frequency we have to directly substitute the transfer function in the form of magnitude and polar plots. So let us sketch the polar plot with the required values. So here also we deal about the resonant frequency, resonant peak and the bandwidth. So here we have the maximum value, we call it as output peak. In the graph we have the maximum output value is called as output peak and that frequency we call it as resonant frequency. So three important frequency domain specifications is resonant frequency, resonant peak and bandwidth. And stability analysis using polar plots. So when here also we have gain margin, phase crossover frequencies. So gain crossover frequency. So the gain margin is this plot will be a circular form. We will be having a unity circle. So the point in which the unity circle touches the graph is, and we have to mark that graph to the angle, that is what we call it as gain crossover frequency. Whereas phase crossover is, we will have a zero line. So when the graph crosses the zero line, that point we call it as gain crossover frequency, which is the formula is 1 divided by that value. That's what is phase crossover frequency and gain crossover frequency. So here we have clearly mentioned the unity circle, phase crossover frequency and gain crossover frequency, and this graph will be very interesting to complete. So coming to the applications of polar plots, Nyquist stability criteria, which determines the closed loop stability from open loop frequency response, and gain and phase margins, and resonant frequency and frequency response analysis. Coming to the applications, aerospace, power systems, robotics, and motor control. So wherever the system is searching for stability, so without these calculations and plots, the stability cannot be analyzed. So this type of analysis can be even done through software platforms, and we can ensure the stability before we implement in the hardware side. So coming to the summarize part, in this video we have clearly discussed about the polar plots and what is the importance of polar plot and what are all the advantages of polar plot compared to the board plot. And in board plot we have complex calculations and two different plots are there, whereas in polar plot we can do with the same plots, and frequency domain specifications were included along with the stability analysis, like calculating the gain margin, phase crossover frequency, and gain crossover frequency. So let us meet in the next video. Thank you.